Hello and welcome to this instructional video. This video follows the previous one in which we were looking at the profiling operation and how to define the information needed to create one. In the previous video we looked at how to set up geometry, we looked at selection of the cutting tool, and we looked at the specification of the cutting speeds and feeds for the operation. The remaining two tabs we'll cover in this video, which is the last tab on how to set up the approaches, and then the first tab, which is how to set up the machining strategy for the profiling operation. Now typically you would do the fourth tab and then double back and do the first tab, although that's not strictly speaking a hard and fast rule. In this case I'm going to actually do the first tab first before doing the approaches and retracts, because the first tab will help in the discussion or the explanation of what some of the approaches and retracts are that one needs to set. So we're going to go to the first tab and we're going to go through and define how do we go about moving the tool, what's the toolpath strategy for doing this particular operation. So again, to recall, we have this circuit that we're going to drive the tool around. The very first thing that we need to look at is what type of toolpath style do we want to use, and there are a number of different options here. Zigzag means that the tool will go all the way around, make a circuit, and then it will reverse direction and go around in the opposite direction, probably at a different depth of cut or at a different radial step in. The next option is one way, and that means that the tool only goes around in one direction, meaning that at the end of a single pass, if it's going to then move to either a pass that's closer to the boundary or one that's at a greater depth, it's going to have to lift up and then reposition to the same start point as the previous pass and then repeat. So the tool moves in one direction all the time, and if you recall from your understanding of climb and conventional machining, this is a good way to help enforce the tool climbing or being in conventional milling mode. So we're going to go and use the one-way approach. We're going to have the tool go around one loop and then repeat in the same direction. We're going to use climb milling as our direction of cut. And again, with climb, if you click on the little question mark, it means that the cutter direction is moving. So the teeth here are engaging and taking a larger chip at the point of engagement and a small chip on the exit. If the tool was rotating the opposite direction, it would be scraping here and ending up with a larger chip here. This image is a little bit misleading. I would have probably flipped the feed direction here. I think it means the tool's motion, but again, typically the feed is into the tool, so a little bit misleading here. So that's our direction of cut. Machining tolerance is typically important if you are machining curves, a lot of curves. In this case, we're doing a lot of straight line segments, just arcs on the corners. So we probably don't need to change this. We're not really too concerned about machining accuracy because of this. The type of contour here, again, the question mark is helpful. This tells you how the tool would go around sharp corners. And there are a couple of options here, or 3 or 4 options actually. So angular means that the tool comes to a stop and then reverses direction. So this would probably leave the sharpest corner. The problem with this is that the tool has to decelerate and come to a complete stop and then reverse direction. So again, this is not necessarily the best way to be efficient, to maintain speed if you're cutting. It also can tend to jerk the machine around quite a bit, because the machine, if you're slowing down from a very fast feed rate, the machine has to pretty much bring all that mass to stop and then reaccelerate it, then accelerate it. So again, it tends to be hard on the machine to do this. So typically circular is a good choice in terms of keeping the cutter moving as it goes around a corner. You don't get as sharp an edge. However, sharp edge is another great thing to have anyway. So the rounding tends to round off the edge a little bit too. So we're going to go with a circular contour. The next option down here is whether or not we want to close the toolpath or not. So what this means is whether or not the tool is the path is going to be closed, because sometimes you can leave it open, typically if you have an open profile. However, if you have a closed profile, it's always a good idea to go ahead and close the pad. And it's also useful to have a little bit of an overlap, because if you start and stop at exactly the same point, you might end up with a mark on the final surface, particularly on the finishing pass. So again, if we click on this question mark here, it shows, okay, that we're going to have a 50% overlap, 50% meaning 50% the diameter of the cutter. And that's probably fine for this application. The remaining options here are not important. So this defines our machining strategy in terms of the tool path style and so on. The next tab over is our step over. And for profiling, there are two types of step over. I'm going to go back to my side view here. So the two types of step over one has is you may have to do multiple passes to move in to remove the material if you have a lot of material on the side. So again, if I unhide the stock, right now we probably have about 50 thousandths, maybe a little bit more on the side, but that's not always the case. Sometimes the stock boundary can be way out here, for example, and in that case it's not possible to take all of that material in a single radial pass. This is the radial direction. So we have to increment in, we have to move in one pass at a time. Also too, we have to drop down in depth. And again, if we had a huge chunk of material out here, it would not be possible for the cutter to be at full depth. Again, depending on the radial thickness at the same time too. So one has to look at both the radial engagement and the axial engagement simultaneously. So one has two options. One has two directions that one moves in, radially and then axially. And the sequencing that one follows depends on which one does first. So again, the question mark here helps explain this. So it shows you here the sequencing being radial first, meaning that if we have a very thick amount of stock to remove, the cutter will remove some of the stock and then move in radially. So it'll go from 1 to 2 and then move out, drop down, do 3, 4, and so on. So that's one strategy. And then you have the axial first strategy, where the tool, rather than moving in, it moves downwards. So it removes 1, then it removes 2, 3, and then when it's got to depth, then it repositions and then moves inwards and does the next radial pass. We're going to use the radial first strategy, so we're going to work our way in at each level. Now there's so little material here that I'm anticipating that we probably only need one radial pass anyway, so this is probably just an academic discussion at this point in time. But you will run into operations profiling in the second setup where you do have to have multiple passes, and that this becomes a consideration. So our radial strategy tells us how do we position the tool, or how much do we position the tool radially. And in this case here, we have one path, and we're telling it that the distance between paths is 1.5. So if we click on the question mark here, this shows you again the number of passes, meaning how many passes around starting on the outside working in do we want. And in this case, because the material we're removing is so thin, 1 is probably sufficient. If we had multiple passes, this would tell CATIA how far to keep each pass apart. So we can control it using this dimension here. So these are the two that are important for the radial strategy. And then the axial strategy is, this is the tool now moving downwards, so moving along the axis. So we have a couple of options as to how to set our depth. We can have a maximum depth of cut that we want to set, or we can input the number of levels we want, and so on. So the number of levels, if we define 12, so remember how we picked the bottom. We picked this surface here and we did a bit of an offset. So CATIA calculates this distance here, and then based upon that distance and the number of levels, it calculates the maximum depth of cut per level. We're going to go ahead and use maximum depth of cut, and let's set this to 50 thousandths. Actually, I'm going to go to 100 thousandths on this. So it means that we're going to take 100 thousandths depth of cut, probably 50 thousandths radially, and we're going to work our way downwards. And it's going to take 6 levels, so the cutter is going to have to drop down 6 times to get to slightly below the bottom of the surface that we selected for the bottom. There's some other options here, but these aren't that important if we're not doing things like draft and so on a given surface. So again, the radial strategy, we're going radial first. Radial strategy is one path. We don't really need to worry about distance between paths because we only have one path. And our axial strategy is maximum depth of cut. We're going down 100 thousandths, so it's going to be 6 passes to get down to depth. And then finally, we have our finishing strategy. So let's say we want, in this case, a finishing pass. In this case, there's no bottom because that all this material here is going to be removed in the second setup. So we're going to go ahead and just add a side finish on the last level. So it means that once we have gone down to the bottom, the tool is going to come back and do a finishing pass at full depth all the way around the boundary. So we need to tell it how much material we want to leave. So again, the question mark tells us what that is. And we're going to leave 10 thousandths of an inch, 0.01, for finishing. And this other input here is not that important. And then this last tab is not something that we need to be concerned about unless we're doing high-speed machining. So those are the 3 tabs that need to be set: the tool path strategy, the step overs, both radial, axial, and then what type of finishing pass we want. So we're ready to generate tool paths. I still have to do the 5th tab, but let's look at what we have before we go there. So let's click on our replay tool path. And let's zoom in and have a look. And what we should see is, as expected, we should see us having, 6 levels. So 1, 2, 3, 4, 5, and there is a 6th level there. It's overlapping. It's very close to the finishing level, which is the light blue color. And then yes, there's the finishing pass, which is light blue. The approaches and retracts, right now we haven't set these, so they are all jumbled up here at the beginning of the pass. We will do that shortly, but let's just look at our tool paths. I'm going to just replay this, and we can see how the tool moves. It moves around, drops down, does each level, and then finally when it does the finishing pass, it lifts up. So in this video we talked about the strategy for machining. In the next video we're going to talk about how do we deal with having good approaches and retracts so that the tool can work its way into the material at the starting and finish, and out of the material at the finishing location.